Looking at 9.3 today, 9.3%. Percents is the topic for today. So percent can be broken down into the word per, the two words per and cent. And cent is a prefix for 100. So it's per 100, or in other words, for every 100. And then this circle right here just lets us know what the percent sign will represent for us. 1% is going to equal to 1 over 100, or in decimal form, 0.01. As always, if I scroll up and you're still copying, always feel free to pause them. All right. So first conversion that we're looking at is percent to decimal. Going to locate the decimal, move it 2 places to the left, and then remove the percent sign. Talking about converting a percent to a decimal. Locate the decimal, move it 2 places to the left, and then remove the percent sign. All right. 25%. If you don't see a decimal, they assume you know it's to the right of the rightmost digit. So that decimal would be beside the 5, to the right of the 5. So if you're trying to convert 25% to a decimal, you take the decimal, move it 2 places to the left, and that's going to be 0.25. %. Take that decimal, move it 2 places to the left, and notice there's only a 1 to the left of that decimal, so we would use a 0 as a placeholder. So that's 0.0139 as a decimal. And then 0.6%, same type of deal. I want to convert that to a decimal, move it 2 places to the left, use zeros as placeholders as needed. So that would be 0.006 as a decimal. All right. Questions before we go to the next one? All right. Let's look at decimal to percent. All right, decimal to percent. Locate the decimal, and this time we're basically doing the reversal of what we just did with percent to decimal. Locate the decimal, move the decimal 2 places to the right, and then place your percent sign. All right, so if we have 0.38 and we want to convert it to a percent, move the decimal 2 places to the right, that'd be 38%. 2.7, 2 places to the right. We only had a 7 to the right, so we need to use a 0 as a placeholder. That'd be 270%. Then looking at just the number 5, once again, if you don't see a decimal, they assume you know it's furthest to the right of that last digit. So in this case, that decimal would be to the right of the 5, and you move it 2 places to the right. That would be 500%. Use zeros as placeholders. All right. Questions? All right, next one, percent as a fraction. So remember we mentioned before when we first started talking about percent that the percent sign represents 1 over 100. So we're going to replace the percent sign with 1 over 100 if we're trying to convert the percent to a fraction. Replace the percent sign with 1 over 100 and then multiply and simplify if necessary. All right, let me erase some of this stuff. All right, so 25%, if I want to write that percent as a fraction, I'm going to replace that percent sign with 1 over 100. Now, don't forget, whenever we're multiplying fractions, you can either reduce first and then multiply, or multiply then reduce. So what I decided to do was to go ahead and reduce first, recognizing that inside of that 100, inside of 100 is 25. Right? So those 25s can cancel. And that would leave me with 4 left over from that 100 and only 1 in the numerator. So that's how I got 1 over 4. Now, if you had multiplied across and did 25 over 100, it still should reduce down to 1 over 4. So on the next one, I actually just went ahead and multiplied across. Once again, doesn't matter which way you do it. I just did them both ways so you can see it worked out both ways if you haven't seen it in a while or whatever. So we have 120%. Once again, you replace that percent with 1 over 100. And notice this time I just multiplied across. So that gave me 120 over 100. Now these zeros in the back of each number can cancel out. That represents 10. So that's 10 over 10, which cancels for me. Leaves me with 12 over 10. Then if you break up 12, that's 2 times 6. 10 is 2 times 5. Those 2's can cancel. And final answer is 6 over 5. All right, questions? Any questions? All right, let's look at one more. Let me erase some of this stuff so I'll do it. All right, so I had 33 and 1/3%. So before you do anything with the percent, go ahead and convert that mixed number to an improper fraction. That'll be the best way of handling this type of problem. So we have 33 and 1/3%. So we take that 33 times about 3, add it to 1. 33 times 3 is 99, plus 1 is 100. And so notice that's 100 over 3, and we still have the percent sign. So I have not done anything with the percent sign yet. All I did was convert that mixed number to an improper fraction. All right. Once you do that, then take your percent sign and substitute in 1 over 100 for it. 100 over 100 will cancel, leaving us with just 1. And that will be 1/3. All right, Mr. Marquise, got your hand raised?
Yeah, I just could you go back and re-explain how you got the 3 plus 1 at the top?
All right, you said, okay, yeah. I see what you're talking about right here.
Yes, sir.
Yep, not a problem. So when you want to convert, what right now, that's a mixed number. And we want to change it to an improper fraction. As a matter of fact, this 6 over 5 is an example of an improper fraction, talking about when your numerator is greater than your denominator. So what we do is we'll multiply the whole number, which is 33, times the denominator, which is 3, and then add the numerator. And so that's where this comes from. So we keep the same denominator. Those 3 are still in the bottom. That stays the same. But you multiply the whole number times the denominator, and then add the numerator.
Okay.
All right. All right. Any other questions on that? Make sure we're good. So convert to an improper fraction, then substitute percent 1 over 100 for that percent sign, and then reduce. Saw that 100 was in common with both top and bottom, and that cancels, leaving us with just 1/3. All right. All right, so fraction to percent. So we just did percent to fraction. Now we're looking at fraction to percent. So here we're just going to convert the fraction to a decimal by division. So, if you have 2 over 4, just throw it in your calculator, get the decimal value, decimal representation of that fraction. And then we'll convert the decimal to a percent. Move the decimal 2 places to the right, like we did before. So 3/4 is 3 divided by 4. 3 divided by 4 as a decimal is 0.75. Then move that decimal 2 places to the right. It's going to be 75%. All right. 5/8, same type of deal. 5 divided by 8, 0.625. Then take your decimal 2 places to the right, 62.5%. All right, any questions? Okay, got a little bit left, and then we'll be done with 9-3. All right, here. Solving percent problems. You can set it up one of 2 ways. You can either use the proportion, or you can use an equation. Either way, they'll give you the same answer. So we'll do a couple problems. Do it both ways in the examples that we have, just to show you how you can set it up. And but either way, you'll get the same answer. So you can do percent over 100 equal to the amount over the base. Your amount, another word for your amount is part, and then your base is whole. So you could look at it as part over whole. I actually said it down here as well. Your base is your whole or your total, and your amount is the part. And then as far as the equation is concerned, percent times base is equal to amount. Like I always say, PVA, a percent of the base is equal to your amount. And then here, this is going to be a decimal. Notice in this part, there isn't a decimal. You just put the number that you have. Here, you actually convert it to a decimal and then do your multiplication. So let's say something. Yep, not too bad, not too bad. Let's see if I put some words on it and hopefully everything will be all right. So yeah, so when you say percent times base, that's a percent of the base is equal to the amount. So let's look at, well, let me give you a chance to write. I want to make sure everybody good before I scroll up. All right. Okay, cool. Let me erase this. So here, the average size of a new single-family house is 2014. In 2014, was 2,690 square feet. This is 158% of the average size of a new house in 1980. What was the average size of a new house in 1980? Round to the nearest whole number. So I'll give you a chance to write that before we get into it. All right, so we're gonna talk about the pieces that we have and basically what the problem gives us and what they haven't given us. So the percent is 158% as a decimal. You know, that's 1.58. We'll use that in a second. X is our base, that's our amount. I mean, that's the total amount. And the amount that the percentage is applied to or associated with is 2690. So what I mean by that is I have 2690 is 158% of the average size. The average size is what we want to look for. So when you're talking about the percentage of that comes after that is your base. So that's why I said in this statement right here, the amount is the percent of the base. So when you start talking about setting it up, remember I said your amount goes over the base. So that means our amount is 2690. Base is our X. And your percentage is always set over 100. So really, the percentage part is not the issue. It's making sure you know which part is the amount and which part is the base. And if you look at it like this, the amount is the percent of base. Look at that statement. So that means amount is right here, and percent of whatever you're taking the percent of is your base. So going back to our statement, 2690. This is 158% of the average size of a new house in 1980. And then they ask us what was the average size of a new house in 1980. So whatever you're taking the percent of, whatever you're applying the percent to or multiplying it to, that's going to be your base. And so if we set it up using the proportion, that's going to be 158 over 100, 2690 over X. And if you're using the proportion, and let me see if I put that down here. Okay, I'll put that down here. Now looking at the equation, we'll solve it in a second. Looking at the equation, you're always looking at PBA, percent times base, is equal to your amount. That's the same statement that's right here. Amount is percent of base. Of means multiplication in mathematics. So, and then is the equal sign. If I can, they won't let me write it there. Yeah, is your equal sign. So A equal to percent times base. So if you want to know PBA, remember PBA or APB. You know, maybe people can cop shows APB. You know what I mean? Y'all know. So hopefully nobody has experience with APB. But you know, the cop shows, you know, they put out an APB. The amount is the percent of the base. So you can do that as far as your equation is concerned. And so we set that up this way. So now, if you want to solve the proportion, you're going to cross multiply. We talked about cross multiplying before. Take your denominators up, 158 times x, 100 times 2690. Then divide by 158. That's what we did here. And that will give us 1702.53. But then they told us to round to the nearest whole number. So that's why I have 1703. I should have kept that purple, but all right. So now solving the equation, notice we're going to get the same answer. I have 1.58x equal to 2690. Divide both sides by 1.58, and eventually we'll still get that 1703 right here. So either way will work. You only have to do one of those ways. It's up to you which one you want to do. All right. Questions before we do another one? All right. According to the Bureau, in a recent year, the average American family had an income of $66,877 and spent $6,759 on food. What percent of the family income was spent on food? And it tells us to round to the nearest percent. All right. All right, so let's look at how we're going to set this one up. So the percent is what we're looking for, so that's going to be our X. Our base amount is the $66,000 that we make in a year, and then the part is going to be how much is spent on food. So you have the total amount of money that you spend per year, 66,877, and then you have a part of that, which is 6,759. That's how much you spend on food. So that's our given information right here, and they want to know what percent of the family income was spent on food. So as far as setting up the proportion, that's it right there. X over 100, remember we don't know the percent, so X over 100, and then the amount over base, or the part over the whole, part over total. So in this one, we can go ahead and cross multiply, or if you just want to take the shortcut in this case, we could by multiplying both sides by 100. And we see that the 100 will cancel, leaving us with just X. 675,900 is not what we have in our numerator. Divide that by 66,877, and that'll give us 10.106. And it tells us to round to the nearest percent. And so that's why we have 10% right there. All right. Questions before we look at it in the equation form? Okay.
Can you go back up a little bit?
Right here. How much farther? Keep going.
No, go a little bit down, like the
Just
red
the
part.
just the red. Okay, gotcha.
Okay, I'm good.
All right. All right. So the purple is the same problem, just written in equation form. Like I said, it's up to you which one you want to be proficient at or efficient at. Here, PBA, once again, percent times the base equal to your amount, and that's what I did here. Your percent was unknown, that's your X, times the base, which was 56,877, and it equal to the amount, which was 6,759. Divide by the 66,877, and that gave us 0.10160, which is the same number we got up here. It's just that this one is in decimal form, so just don't forget to move that decimal 2 places to the right. All right. So we got one more thing to talk about in this section, but before we go there, questions. Make sure we're good. All right. Next thing is percent increase and percent decrease. We're going to calculate these, both of these, the same exact way. So when we talk about a percent increase, you're going to find the amount of increase divided by the original amount, multiplied by 100%. Percent decrease, find the amount of decrease divided by the original amount, multiplied by 100%. So it's going to be the same process in both cases. We're going to subtract our two numbers, divide by the original amount, multiply by 100%. All right. So, example of that, find the percent increase in the federal debt from 2005 to 2010. So, 2005, now there was a chart for this, for these figures, so that's where I got it from. In 2005, there was $7.91 trillion in debt. In 2010, it rose to $13.53 trillion in debt.
I'm sorry, will you go down a little, let me go back up a little bit? Thank you.
Mm-hmm. Just let me know when you're ready. All right. Are we good to go? Slide up. Yes, no, everybody good. All right. So, percent increase. I want to find a percent increase in the federal debt from 2005 to 2010. Like I said, we got these two values from the chart. There was a chart that was in the book. 2005 says 7.1 trillion. 2010 says 13.53 trillion. So, all you would do is find the amount of increase by first subtracting those two values from each other. 13.53 minus 7.91, give you 5.62. Then we take that 5.62 divided by the original amount. Our original amount was at 7.91 and multiply times 100%. All there is to it. Questions? Any questions?
Why does it subtract them?
Because you want to know how much did it increase. So you had this amount, which is 7.91. You want to know how much did you add to the 7.191 to get to 13.53. So that's your amount of increase. Same thing if you're talking about the amount of decrease, subtract the two values because you want to know how much it was taken away from the larger value to get to the smaller value.
Do you have another problem like this?
Down here, I was just somebody asked about decrease, so it's the same type of thought process. They'll give you values for 2000, let's say 2005 to 2010, but this time, let's say it goes from 10.9 to 6.4. Same thing, we're going to subtract them from each other. That will give us 4.5. Take 4.5, divide by the original amount. The original amount was whatever amount you started off with, initially. So in 2005, they had 10.9, and it went down to 6.4. So we take that 4.5 that we got from, that's the amount of decrease, place it over to 10.9, multiply it by 100%, and that'll be your answer. So all you do is subtract your two values, divide by the original amount, multiply by 100%. Yep, not a problem at all. Somebody sent the message. All right. So questions?
For 100%, if you're doing it like on paper, could you do like 1/100?
Now you would just multiply by 100. You would just move the decimal two places to the right. If you're just talking about doing it on paper. If I multiply, if I have 0.79 and I multiply that times 100%, that's going to be 79%. You just move your decimal two places to the right. Or if I have 2 and I multiply that times 100%, that's going to be 200%. If I had 3.1, multiply that times 100%, that would be 310%. You just move the decimal two places to the right. Was that your question? Did I answer your question? Make sure I'm good.
Yeah, I'm all right.
Okay, good. All right. So, Mr. Fernandez, did you say something?
Yes, sir. Can you please just go up just a little?
Mm-hmm.
Thank you.
Mm-hmm. All right. Any questions about anything said today? Any questions? All right. Just scrolling up. Okay. So 9.1 through 9.3, we've already talked about those three sections, and that's all you held accountable for in chapter 9. So next class will be a review day, the 23rd, next Tuesday. I will not cover any new material next class, but it will be your opportunity to bring whatever questions you have to class that day. Um, so it's up to you guys to take advantage of that. Even if you have questions out of chapter 7, that stuff is still open as well. So bring your questions to class on next class, so we can knock them out. If you have any issues, anything you want to see me do that, even if you haven't made an attempt, you just want to see me do it because you couldn't figure it out, whatever the case may be, you can bring it to class on Tuesday and we can take care of those. Questions about that? Any questions?
Nope.
Thank you, Professor. No.
Not a problem, no problem. Also, take a look at the review, because even if you don't do the review, remember, it's not mandatory, but you should at least take a look at it and see if you have any questions out there, because remember, it's going to streamline your studies as far as what will be on your test. So even if you just look at the review and say, hey, can we do, I saw this problem in the review, didn't know how to do it, we can do that. That's what Tuesday will be for. So, then they pops up. I say, so, okay, cool. Looking in the chat, y'all. When is everything due? I've been packed. Myself. Everything should be due by week 5. Week 5 grading period, not grading period. Progress reports. I need to turn those in week 5. I think we said that's about 2 weeks away. We got started 1, 2, 3, 4. Yeah. So let me get that date and see when they want those grades in by, and then we'll be looking to do that. Have like chapter 7, chapter 9. Not sure if 10 is going to be included, but at least chapter 7 and chapter 9 will be included on that 5th week progress report type grade. And so everything will be due by that. Everything from chapter 7 and 9 I know will be due by that week. Somebody said never got a response to the email. Depending on when you sent it, if you sent it on Tuesday, I may have missed a few of those because I got behind. I got most of them from Tuesday, but it's a possibility. So if you send it Tuesday, then I'll make sure I answer those today, Tuesday, and make it current. So just give me a second or two to get to those emails for those who said they didn't send one. Now, if you sent one past Tuesday, if you sent it Monday, Saturday, or Sunday, or something like that, then I didn't get that because I've been combing through the emails. So, but if you sent it on Tuesday or beyond, Tuesday, Wednesday, something like that, I still got to get to it. So I said on the review, okay, Ms. Baker, do you know what the problem is, or?
It's the last one on the review.
Well, I'm saying you don't have it. I got to look it up.
Yeah, you gotta look it up because it's weird
See,
anyway.
no, whatever, man. You just making
I got
work.
stuck on the last one.
No, you supposed to bring it to class, so I didn't have to look it up. That was called, trying to make me work. I mean, I don't get that. Let's see. Let me log in real
Because
quick.
the problems on the review are the same as on the test, and we don't know how to do that. So I left them blank on both.
Is that so?
Yeah.
All right.
So it's not that hard, but I don't understand how I'm supposed to do it.
Yeah, not a problem. Now, that's the only one, because it sounded like you said problems. Was that the only one?
That's the only one. The
Okay,
other ones we went over.
Okay, got you. So guys, I'll say this: if you want to stay back for a question, feel free to stay back. It may help you out. But if you're done with math for the day, feel free to roll on. I'm not gonna do anything new. I'm done with lecture. Next class we'll be doing review as well. So if you want to stay back, feel free to do so while I look up a problem. Just give me a second. But outside of that, you guys have a great weekend. Be safe, and I'll most definitely see you next class.
All right, big bro.
Professor.
Yeah,
Have a great weekend.
All
as
right.
well, so.
Thank you. Y'all take care. Just taking. There we go.
Because it's like a box, and it has a hole in the box, and it doesn't I don't know how I'm supposed to calculate it.
Yeah, I'm getting to it. Trying to get to it anyway.
And to make it so funny, it's the exact same problem as the last problem on my test. And I was like, man, should have asked first.
It's all good. See, Conyers. See that you say you resent it, so I'll check that out. All right, so let me share, make sure I got the right problem before I start doing stuff. Let's see. All right, so this one right here, number 26?
Yes.
All right, not a problem. Let me see if I can draw it. somewhat decent. All right, yeah, don't look too bad. All right, and then we got like a 2, 8, 4, 4. So we got 2, 8, 4, and 4. Okay, so what we need to do here is you will find the volume of the, it's not a, I'll just say a rectangle for lack of a better word. It's not a cube. And notice also in here, this missing piece, that's actually a cylinder, like half of a cylinder, all right?
Okay.
So one, we're gonna find the volume of the whole rectangle. Then we're gonna find the volume of the missing cylinder. All right, somebody said something in the chat. Okay, yeah, not a problem, sir. I mean, it'll be recorded if you want to see us, talking about this. So you take volume of the rectangle minus 1/2 volume of the cylinder. So that's how we'll do it. Volume of the rectangle minus 1/2 volume of the cylinder, and that will equal to the volume total. So let me see, where is my, yeah, it's right here. Let's see, this is 7 point, I think this is out of 7.5. I want to make sure I got my cylinder volume formula correct. Cylinder, okay. All right.
Pi radius to the second power times height, right?
Let me see what you got. You said pi
Times radius
squared height.
yeah,
Yep,
square.
you got it right. Mm-hmm. So that's what we're looking at. Now going back to my rectangle, we're looking at 8 times 4 times 4. I'm gonna write the dimensions just for note purposes. And then here, so for the volume of the cylinder, we need a radius and the height. So the height of our cylinder is going to be 8. That's how long the cylinder is. But then notice here, and let me make sure I confirm. Yeah. So this is the diameter. They gave us the diameter. So let me write this. The height is 8. They give us the diameter is 2. So that means the radius, which is 1/2 the diameter. And I'm just writing all this out just in case, you would get another problem. So our radius is going to be 1. All right. Any questions so far?
No.
Mm-hmm. So now we're looking at the volume. It's going to be 8 L times 4 times 4. That should be 124. Got 1, 3, 2. Got 128. And then here we're looking at the volume of the cylinder as pi times r squared times 8. So 1 squared is just 1. 8 times 1 is 8. So it's 8 pi centimeters cubed. So that's without doing any type of approximation, 3.14 type stuff. So we'll take both of these pieces. And then, like I said, going back to our trying to get to this final answer of the total volume, we're going to do the volume of the rectangular, cubic rectangular. I know there's a better word for that. Anyway, minus 1/2 of the cylinder, the volume of the cylinder. So that's 128 minus 1/2 of 8 pi. 128 minus 4 pi. Now let me go back and see how they want the answer. It said round to the nearest unit. So I would just put that in the calculator. I would do 4 times pi. I wouldn't do 3.14. I wouldn't round till the end.
Yeah, I usually just put like 4 pi or whatever in the calculator.
Minus 120. So it should be 115.434, and it's at round to the nearest unit. So it'll just be 115 cubic centimeters. Now, let's make sure our stuff is straight. Go put that in there. All right, 448. Hold on 1 second. Did I put something in my calculator wrong? C2. Make sure I did that right. Right, minus 128. Did say round to the nearest unit. Oh, hundredth of a unit. How did I miss that? So that's 434. Yeah, okay. So now they said hundredth of a unit, so it's 4.43. But yep, so that's how you do it.
Okay, thank you. That was the only one I got really stuck on. So
Okay, sounds good.
also, are you gonna when are you gonna post this lecture? Because like I said, I was in the middle of my test, and so I didn't log in until after I got done.
Yeah, between tonight and tomorrow morning, I'm gonna try to get it done. I have a class though. I have a meeting about to go to now. Then I have a class that picks up right after that, and I'll be in class almost 9 o'clock. So I'll try to get it done for y'all. I had another person that requested it as well.
Okay.
So yep.
Thank you.
All right, not a problem. All right. So if everybody else is good, you guys have a great weekend.